Question number 5.279. A photoelectric current emerging in the circuit of vacuum photocell. When it's a zinc electrode, it's subjected to electromagnetic radiation of wavelength lambda is equals to 262 nanometer. It is cancelled if external decelerating voltage, or we can say V stopping potential, that is 1.5 volt. Find the magnitude and polarity of the outer contact potential difference between a photocell. Okay. So basically this problem is saying that suppose there is a zinc plate. Okay. In this some light is falling and it is generating a photocurrent. And here we connected an electrode. From there current is coming out. Now if we apply a reverse voltage of 1.5 volt, then we do not observe any photocurrent. Okay, it means basically this is stopping potential called for. Okay, so we have to find out this contact potential, right? Okay, so first of all we need to determine energy emitted for electrons from this zinc surface, and according to the photoelectric effect, the energy emitted by a photoelectron, or energy of an emitted photoelectron I must say, is equals to energy of photon falling on this surface minus work function, right? This is h nu minus work function. So we can write this energy is equals to hc over lambda due to this wavelength minus work function of zinc. Again I am repeating the same thing, that in some books you may see expression like this, because this h cap is equals to h over 2 pi, right? Now see, so the work function for a zinc plate is 4.33 electron volt. Here we can perform entire calculation in terms of electron volts, so this h can be the Planck constant, that is 4.13 into 10 to power minus 15 electron volt, and rest of information is available, that lambda is equals to 262 into 10 to power minus 9, right? And the speed of light is 3 into 10 to power 8 meter per second. Okay, now if we'll substitute in this expression, then we may get the energy of this emitted electron is 1 electron volt. Okay, it means the exact stopping potential required for this photoelectron, if we'll ignore the effect of contact, is V stopping, which is equals to 1 volt. Okay, but in this case we required 1.5 volt external voltage to stop this emission. So it means the contact potential must be equals to V applied minus exact stopping potential. So this is 1.5 minus 1 volt, which is equals to 0.5 volt. So in this photocell, the contact potential is of 0.5 volts.